Alright, so the second part of the video here is going to be about arc length instead of arc measure. So arc length is going to be a measure of the outside, how long a piece is on the outside here. So not how many degrees this is, but maybe how many inches or centimeters or something like that. Alright, so in order to get that, kind of like how we were taking a chunk out of 360 for the arc measure, we're going to take a chunk out of the circumference for arc length. So that's what we'll get to in a second. First thing we got to remember is that there are two formulas for circumference. All right, where D stands for diameter and R stands for radius. So either pi times diameter or 2 times pi times the radius. All right, a diameter is all the way across, and a radius is only halfway across. All right, so depending on what they give you, that dictates what you should use as far as the formula goes. So, and then we'll come back to that word concentric in a second. Okay, well, let's just look at the circumference of these. 22 is your diameter this time, since it goes all the way across. All right, so remember that our formulas are either pi times diameter or 2 pi times the radius. So depending on what they give you, you can choose a formula that works. Since they gave us a diameter for the first one, I'm going to use pi times diameter, or pi times 22. All right, if they don't tell you how to round, I would leave them in terms of pi. So I'm just going to write the 22 first, and then we're in meters. This is not a square unit because we're not talking about an area, we're talking about a length. So the circumference now is like the perimeter of the circle. That's how much distance there is all the way around. Second one here, they gave us 16, which is a radius. So for this one, I would use 2 pi r. So the circumference of this one is 2 pi times a radius, which is 16. I'm just going to multiply the 2 and the 16 to 32, leave pi in my answer, and call that 32 pi inches. All right, remember, pi is about 3.14, so we're talking about something in the high 60s or 70s for that final answer. This one as well, we have a radius, 6.8, so I'm going to choose the 2 pi r formula, which is 2 times pi times 6.8, which is going to be just doubling the 6.8 and leaving the pi as part of the answer, so 13.6 pi meters. If you leave it in terms of pi, like I'm doing, you don't have to go to the calculator, but remember to write pi as part of your answer. Otherwise, you'll be off by a factor of 3.14. All right, so just one problem or one word problem talking about concentric circles. So let's back up to the same word from up here, coplanar circles that have the same center. That's called concentric. All right, so concentric circles are just 2 or more circles that have the same center. So this same center is the center for this blue circle as the green circle around it. They're called concentric because they have the same center. Okay, so here's a problem regarding that, finding distance with circumference. Remember, circumference is that distance all the way around the circle. So here's what we have, a 2-foot wide circular track for a camera dolly is set up. The 2 rails of the track are concentric. That means that I have a picture something like this. I have a track, I'll have like an inner track, and I'll have an outer track. That 2-foot wide part comes in this distance. This distance is about 2 feet. Okay? The radius of the inner circle is 8. Okay? So that means that this distance here is 8, and we're talking about feet. Right? How much further does a wheel on the outer rail travel than a wheel on the inner rail? So it's a how much further. So what that means is we need to figure out the circumference of the big circle and take it away from the circumference of the small circle. So that's what we're going to do. We're going to get the outer circle, the outer circumference, and subtract the inner circumference, and that'll tell us how much more the outer wheel has to travel compared to the inner wheel. So we're dealing with the radius for both of these, so we're going to do 2 pi r for both. It's just going to be a different r for the 2 circles. So we have to figure out this outer radius in a second. This inner radius is going to be something that they gave us. Okay? So for this one, they gave us that the inner circle, the smaller circle, has a radius of 8. All right, which means if we have a 2-foot wide track, this is 8, and then this is 2 more, so a total of 10 is the radius of the big circle. So we have a 10 that goes here. All right, so right here we have 20 times pi. I'm going to leave pi in it right now. Here we have 2 times 8, which is 16 pi. Now, since these both have a pi in them, it's kind of like we have like terms here. It's same as if it would have been 20x minus 16x. I can just subtract the 20 from the 16 and get 4 pi. Since it's a word problem, we would want to type that in. It's about 12.57 feet. So that's how much further the outer wheel has to travel compared to the inner wheel. All right, there's 12.57 more feet of circumference there. Okay, so getting into arc length now. All right, here's the main idea for this video. The measure of an arc is in degrees, while arc length is a fraction of the circumference. So the units might be in inches or feet or meters or miles or whatever. Okay, we have the same exact idea as arc measure, where we're taking something out of 360 degrees. So we still have to know the arc measure in order to find the arc length. All right, so here's a good formula for it. If I wanted to figure out the red arc right here, how long it is, I need to know the measure of it, which is the amount of degrees. So the arc length, it's going to be the measure of AB, that's in degrees, of 360. That gives us, again, the fraction of the circle times the circumference. So that could be 2 pi r if they give you a radius, or it could be the measure out of 360 times pi times diameter. It's just multiplying how many degrees you have by the circumference. All right, so that's your formula. I know it's kind of 2 different formulas, all right, but it kind of depends on what we're looking at as far as did they give you a radius or did they give you a diameter. So to get arc length, we need to know the radius or the diameter, and we need to know how many degrees this is. Okay? All right, let's try a few. So it might be hard to tell on your packet, but we're finding this distance here. Maybe you want to highlight that a little bit better. We want to find out how long that is. Not the measure of it, not how many degrees, how long that is in inches. It does say leave in terms of pi, so we have that going for us. All right? So in order to know the arc length, we have to know if we have a diameter or a radius. This time we have a diameter. All right, and we have to know how many degrees the arc XY is. So if this is a 90 here, remember from the first video, this is called the central angle. If this is 90 degrees, this is 90 degrees. All right, if it's 90 in the center, it's 90 on the outside. So what I have this time is 90 out of 360 of my circle, okay, times the circumference. This time I'm going to use the pi times diameter circumference formula since they gave us a diameter. So really the length of this is saying I need, so I might simplify this down to 1/4. I'm asking myself, or the question is 1/4 of 16 times pi. We're leaving it in terms of pi, so all we need to do is take 16 divided by 4, and that arc length is 4 pi inches, the length from a x to y that time. Okay, let's try it again. This time, again, on your paper, highlight this part of the circle, the long way around. They gave us that that's 240 this time. So the only other thing to find is the radius of the diameter. They gave us a radius this time. So what we have for this one is we know that we want 240 out of the 360 degrees. We're multiplying that by 2 pi r. 2 times pi times the radius of 15. So 240 over 360 simplifies to 2/3. All right, 2 times 15 is 30. We're leaving the pi out of the calculator part. So really it's asking what is 2/3 of 30? That would be 20 pi. This time our unit is centimeters. So that's the length from x to y. So this is the length of x, p, y. that way around. Okay. All right, so we have that. That's going to be your examples of your arc length. All right, a couple other things we just have to talk about. It is possible for two arcs of different circles to have the same measure but different lengths. It's also possible for two arcs of different circles to have the same length but different measures. So what that means is just having the same amount of degrees does not mean they have the same length. Congruent arcs, though, are arcs that have the same measure on congruent circles. All right, congruent arcs have the same measure and are the same circle or congruent circle. So they're the same size and the same amount of degrees, same length and measure. That's what a congruent arc would be. Okay, just a little vocab word there. All right, last idea here. This is more like the first example. We're looking to find some variables here with what we're given. All right, so they want to find the variable a in this first one here. So all I know is that I have a 2a plus 24 and an a, but they did give us this diameter going through, not the length of it, but we know that that's going through the center. So with problems like this, you want to use 180 if you can, you want to use 360 if you can. All right, since they gave us a semicircle right here, and these are central angles, if this is central angle, if this is a degrees, this is a degrees. If this is 2a plus 24, so is this. All right, so what I know is I have two different arc measures that are going to add up to 180. So since I have a semicircle, I know that that's 180 degrees. So for this problem, I would be adding everything up and setting it equal to 180 degrees. So that's what we would solve there. So for this one, we end up with 3a, adding the 2a and the a together, plus 24 is equal to 180. Subtracting both sides by 24, I end up with 3a equal to 156. Dividing by 3 gives me my answer of a equal to 52. All right, so you have to come up with the 180 there by yourself. Part B, you are not given a diameter, so we can't use that same trick. So for this one, we're left with just using 360. So since they didn't give us a halfway point or even a 90 or anything like that, we know that all we know is that all three of these angles, these are all central angles, but we know that they're going to add up to 360 because that's how many degrees are in the circle. So for this one, we're stuck with adding everything up, which can be kind of a lot to write, adding all the stuff they gave us up, setting it equal to 360. So this time they didn't give us a halfway point, so we couldn't use 180 or any other strategies like that. All right, so if you add up all the a's here, 20, 10, and 2, you get 32a. Negative 30 and 2 and positive 24 will give you, or sorry, just positive 4. That was a mistake there. That's just supposed to be a 4. So what we get when we add all that up is just a negative 24. So 32a minus 24 equal to 360. All right, and then we would solve from there. So we could add 24 to both sides. So 32a is equal to 384. Dividing by 32 on both sides, a should be 12. All right, so really quickly, go ahead and hit pause and try the last one there, and then we'll wrap up the video. Okay, click pause now. So I ran out of room a little bit writing mine, but everything added up to 360 this time. Maybe the trick with this one would be to recognize that you have a 90 right here, which means you have a 90 on the outside. But it would have been adding everything up to 360 and then solving. Hopefully you were able to get x equals 28 on that one. All right, so just as a quick summary for this, all right, arc measure is a fraction of 360. It's in degrees. Okay, arc length is a piece of the circumference. That's in centimeters, inches, meters, etc. Okay, that's a length that is in a unit that we're more used to. But being able to find the arc measure and find the arc length are two different things. So feel free to go back to the length problems on this video just to see how that works, the portion of the circumference, and reference that first video for arc measure. All right, go ahead and give this a shot.